Every license is paid except this one. This one is, even if you pay, this is outdated. You don't get a license for this. But the writing comes good, so I use this. Okay, we start. So the question says it's a gun and a bullet problem. So let me write the given data first, and let me write the given data. It says a bullet of mass 10 gram. A bullet of mass 10 gram. So my first given data would be what? Mass of the bullet. Mass of bullet. And I would want problems to be done exactly the way I teach. You just don't write MB equal to 10 grams. I don't know what is it. You're in the exam also. What do I know? You have to head up. How do I know what is mass MB? Okay, is fired from a gun of mass 6 kg. Is fired from a gun, mass of gun. So we'll write that as mg. Okay, so this is 10 grams and this is 6 kg. In these problems, it does not matter to change the units, but preferably we'll change the units. Okay, 6 kg with a velocity of 300 meters per second. So the third data is velocity of the bullet. Velocity of bullet. Right? Now, how will you write this? Is fired with a velocity of 300 meters per second. But these problems are all momentum before, momentum after. Here, a gun is firing a bullet. So what is the incident? Firing is the incident. So we should change this and write, given final velocity of bullet. After the firing, the bullet takes this velocity, final velocity of bullet. So what will we write this as? VB, 300 meters per second. That's the final velocity of the bullet. So 4 we will say initial velocity of the bullet. That would be UB is equal to 0 meters per second. Why 0 meters? Because initially the bullet is just loaded on the gun. The gun is at rest, the bullet is also at rest. Then the incident happens, discount. Then what happens? Bullet has taken a velocity. So we assume that the bullet will go this side. Now they'll ask us to find the recoil speed of the gun. To find number 1, recoil velocity of the gun. Recoil velocity of the gun. And here I will write this as VG because this is the final velocity of gun. Now many children will have a doubt here. Sir, if the bullet goes this side, the gun should recoil on this side. So why are you not keeping VG as minus? No, we won't keep VG as minus. If our problem is solved correctly, VG automatically will come out minus. Understood? This is the pattern in which we write. So, few things which you will not write, but you will just think in your mind. What is the incident here? Firing is the incident here. Momentum of the system before firing should always be equal to momentum of the system after the incident. So what do we write here? We will write applying law of conservation of linear momentum. Right, momentum of system before firing should be equal to momentum of system after firing. If your signs and everything are correct, there is nothing to worry after firing. So let's put our data. Momentum of the system before firing. So we will have a mass of the bullet into a initial velocity of the bullet. All right, initial velocity of the bullet. Then mass of the gun into a initial velocity of the gun. So we should also write one more data, that initial velocity of the gun, that is UG, should also be equal to 0 meters per second. Fine. Should be equal to momentum after mass of the bullet into VB plus mg into Vg. Clear? Step by step. On this side, everything would be 0 because this is 0, this is 0, this is 0 is equal to mass of the bullet. So the mass of the bullet is 10 divided by 1000. You can do this here also. 10 divided by 1000. Then this comes in kg. Multiplied by initial velocity, final velocity of the bullet. The final velocity of the bullet is 300 plus mass of the gun, which is 6 kg multiplied by Vg. क्या हुआ? बोलो बोलो बोलो. Tell me, if you don't make a face, tell me now. 1 minute, 1 minute. What are her fifth one? Fifth one is initial velocity of the gun. Gun. What do you want here? 0. This is 0. This is also 0. This whole thing is 0. Is equal to mass of the bullet. सोच नहीं सकते ना, ये पूरा side 0 है. So if you bring this side, it becomes negative 6 Vg is equal to, so we can cancel these two out here and cancel this with this, right? Is equal to 3. Negative 6 Vg is equal to 3, which means Vg should be equal to 3 divided by negative 6, which is negative 3 by 6, which is equal to negative half, which is equal to negative 0.5 meters per second. See, automatically we are getting a negative. So we write the gun recoils backwards with a velocity of 0.5 meter per second. Anyone who has not understood anything, please do raise a query. So the story was very simple. We have a gun and a bullet system out here. The bullet was fired. We know the velocity of the bullet. So as the bullet was fired by Newton's third law, there will also be a force. If you have given a momentum to the bullet should also give a momentum back to the gun, and both should always be equal. That's, and the law of conservation of momentum says, linear momentum says that the momentum before firing should always be equal to the momentum after the firing. We were supposed to calculate the recoil velocity of the bullet, sorry, of the gun. We need not take any negative data. If our calculation is correct, automatically the gun, and velocity is a vector quantity. The bullet's velocity was taken as positive, means say bullet is moving in this direction. Gun's velocity coming negative means gun is moving back in this direction. Negative does not means less. Negative means it is opposite with reference to the bullet. Clear? Any doubt, anyone? No issues? Shall we take a next problem now? क्या हुआ अभी क्या बोलो? चलें दूसरे प्रॉब्लम में आइए. Let's take our next problem. This is one of the easiest problem. So our next problem is a car collision scenario. So in car collision scenarios, what happens? Collision is the incident. Momentum before the collision should be equal to momentum after the collision. So let's see what all are given, and if you given. So let me picturize it. A car of mass 1500 kg. So you have car A whose mass is 1500 kg. Car A of mass 1500 kg. Traveling at a speed of, this is traveling at a speed of 25 meters per second, right? Collides with another car of mass 1000 kg, collides with another car of mass 1000 kg, traveling at a speed of 15 meters per second. Now you should ask, सर वेट मैं टाइम दूंगा लिखने के लिए, क्वेश्चन को समझो तभी होगा, otherwise you are just noting down data. This is not how you study physics. Take your time to understand the scenario, then you will not need my help after this step. A car of mass 1500 kg is traveling with 25 meters per second, collides with another car of mass 1000 kg traveling at 15. Your question should be, in which direction is B traveling now? No, it says traveling in the same direction. पीछे से आगे मारा है इसको, and if you see the velocity, its velocity is less, its velocity is more, right? Now some more interesting data we can observe from here. Mass is less, mass is more, speed is also more. So this is like a striker hitting a coin. What do we expect? Its velocity will increase, has to. And in which direction? In the same direction, because the momentum will be imparted on it. Jiska zyada momentum, he only controls the whole game. Okay. After collision, okay. So after that, so there is a collision out here. After collision, car A now travels with a speed of 20 meters per second. Okay. In the same direction, the velocity of car A becomes 20 meters per second. Calculate the velocity of car B. Calculate what is its velocity. We don't even know. Sometimes you will see after hitting this, there can be a scenario where this can come to a stop. Sometimes after hitting this, this may rebound also. We don't know. But this calculation will tell us what happened. Did the striker go in the direction of the coin or did the striker come back? Okay? We have to find this. Understood the problem? Collision is all about, now just check the units, meter per second, kg, everything is good out here. Yes. Post collision. So let's start. So we start writing car A, you can write here, mass is MA, which is equal to how much? 1500 kg. And by now somebody must be solving the problem and giving me the answer. I'm least interested, because it's not about solving numbers, it's about the process in which you're doing. Okay, car A, initial velocity, it will be UA. How much? 25 meters per second. Final velocity. Final velocity is always VA, and VA is 20 meters per second. Car A has slowed down. If you see, look at the beauty of the problem. Car A has slowed down. That means car B will pick up speed. Imagine in a carom board, when you hit with the striker slows down, point picks up speed. Okay, so let's see the data for car B. Car B, mass MB, which is equal to 1000 kg. Then initial velocity UB is 15 meter per second. Final velocity VB is unknown. That is what we have to find. This is basically to find. Or we can write to find. Look, now since I have already defined it, I can just write VB is equal to what? I can write this. We start as per conservation of linear momentum before collision should be equal to momentum after collision. So now you put your equations. It will be MA UA plus MB UB MA VA plus MB VB. Anything, this will be the formula. And why I am not changing any data? See, while you are taking these datas, you have to understand what is written. It was written in same direction. If they would have written in different direction, I'll consider this as negative. The value as negative. Okay, na? Till now, we'll get those problems also. So let's put MA. So this is 1500 multiplied by 25 plus 1000 multiplied by 15 should be equal to 1500 multiplied by 20 plus 1000 into VB. Agreed? Now see how much you can take out. Now starts the beauty of mathematics calculation. You can take out 100 from here. 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 Your calculation becomes easier now. Okay? Further, some more 5s we can take out. If you see, if you take this 5, 2 makes it 10, 5, 3 makes it 15, 5, 3 makes it 15. Acha, why did I not do this as 5 to 10? A 10 is easier to calculate. Okay? And a 5 makes it 25. Got it? So my next step would be, since it's an equation, I put OR. 15 into 5 is 75 plus 10 into 3 is 30 is equal to 3 into 20, 60 plus 2 times of VB. Agreed? So how much are we getting? You can also take down this one also, but this one is odd. Okay, 75 plus 30 is 105 minus 60 is equal to 2 times of VB, or VB stands equals to how much? 5. 10 minus 6 is 4. 45 divided by 2. So 40 divided by 2 is 20 and 5 is 2.5. So this is 22.5 meters per second. What is that sign did I get? Positive. Means the car B continues to roll in the same direction. So we will write here the car B moves in the same direction with a velocity of 22.5 meters per second. Now look, it was 15. Now his velocity slowed down, striker slowed down, so coin picked up the velocity. Clear? There are many beautiful ways of doing these problems. You can actually write car A, car B, write down the parameters: mass, MA, MB, initial velocity, UA, no, UB, final velocity, VA, VB. That's what you can do. That's called your header data. So when you go in study IT also, any file you write code, there'll always be something called header information. If you practice this way, then any other child who looks at your problem also finds that yes, chronologically I've understood everything. You jump step, I jump marks. Shall we take another problem now? Okay. Can I stop the screen? Any doubt you can ask. Charvik, have you understood? Excellent. Our next problem, let's first understand the story. A bullet of mass 10 grams. So let's understand. We have a bullet and the mass of the bullet is 10 grams. This is interesting. 10 grams. It's moving with a velocity, of 400 meters per second. Understood? And then what it does is, there is a freely suspended piece of wood. Freely suspended piece of wood. The bullet goes and hits this wood, and the bullet gets what we call as embedded. चिपक गया, mara and it चिपक गया. Now just think, this is freely suspended. Why did they use the word freely suspended? Freely suspended, bullet has hit, so the plank will also go like this, but the plank has gone like this with the bullet inside it. Very interesting. Okay, freely suspended, and the wooden block mass is 900 grams. Very strategic problem. Look, why did they make it 900? Because after the 10 grams bullet goes inside it, it becomes a 1 kg mass. That's very interesting. It becomes a 1 kg mass. So these sort of problems we call combined mass systems. Initially you were two body. After the event, you became one body. Now please understand, this is bullet and wood. There can be sometimes problems where a car hits a stationary car and then drags that car along. So there also you are a combined body. Are you getting it? You become a combined body. You are not a single body in that case. Right. What is the velocity acquired by the block? The velocity acquired by the block. That is, say VB, we don't know. First, before writing, tell me, have you all understood the scenario of the problem? There is a suspended block. A bullet comes with a speed of 400 meters per second, tuck, hits it and gets embedded, and this moves. It will move. We have to calculate what is the speed. Now tell me, should it move in what direction? In the same direction? My answer of should come positive and much lesser than the bullet speed. All right. So let's start our problem. Okay. So we write given. Okay. So you have a bullet here and you have a bullet plus wooden block. In the second scenario, it's not wooden block, right? So there are three things. Then you also have a wooden block. Bullet, wooden block, bullet plus wooden block. And the incident is happening somewhere here. Do you agree or not? The incident happens here, right? So our first parameter is what? Mass. Shall we write this as MB? And this mass is how much, beta? 10 gram. 10 by 1000 kg. Mass of the wooden block, MW, 900 by 1000 kg. And this is MBW, which is equal to 1 kg. Why 1 kg? 900 plus 10. If you want, I can break it. But it will be a little bit of spoon feeding. But you love spoon feeding, right? 900 plus 10. Hey, don't give me those idiotic answers. I don't mind even throwing water on you. I know those systems will get bad, but the satisfaction I'll get is huge. How it became 1 kg? 900 plus 100 divided by this. Okay? 10 grams. 910. 900 plus 10 divided by how much? 1000. So 910 by 1000. Throw the water back on me. Yes. If somebody does wrong, it's wrong. Simple. Okay? These problems are interesting, yes or no? So let's take initial velocity. Initial velocity UB is how much? 0. Bullet has not yet. Now you have to decode. Bullet has not yet been fired. Firing is the incident. Before firing, bullet was at what velocity? 0. ये समझ में आया कि नहीं? ये data problem में नहीं है लेकिन. You have to find out. So this is 0 meters per second. Then UW is also equal to 0 meters per second. And UBW is also equal to 0 meters per second. Okay? Actually, this scenario though did not get created at all. This scenario did not get created at all. Okay, fine. So there is no sense of writing this. No need. Let's see. What is the final velocity? So that is VB of the bullet. The final velocity of the bullet is how much? Now here we have gone wrong. You have gone wrong here if you have done this way. That's why I said, think about the problem. You will go wrong. Firing is not the incident here. What is the incident? Striking is the incident. Firing is not the incident here. Striking is the incident. So change your data once again. Initial velocity of the bullet is how much? 400 meters per second. Initial velocity of the wood is, before striking, you did not have a combined system. So initial velocity of the wood is 0 meters per second. This is the initial velocity. Now come to the final velocity of the bullet. What is the final velocity of the bullet? What is the final velocity of the bullet? Yes, because it gets embedded. So, and there is no question of something called final velocity of the bullet. We will not write anything for final velocity of bullet. We will just write what is the final velocity of the, this is VBW. This we don't know. Got it? Start thinking now. There is a bullet which is coming. There is a wooden plank which is waiting. This is all before the incident. Incident is tuck. After that, there is one system, one velocity. Shall we now apply? Applying the law of conservation. Applying the law of conservation of linear momentum. So it says initial momentum should always be equal to final momentum. Now you start thinking, what is the initial momentum? You had a bullet, mb, multiplied by initial velocity of bullet. You had a wooden block multiplied by initial velocity of wooden block. This should be equal to, where did the bullet go? Bullet got merged with what? Wooden block. So mbw into vbw. That's all. Now we won't have any other thing. Bullet is not separate. Bullet is a part of the body. So let's put our data. What is mb? 10 by 1000 multiplied by 400 plus, this part will become 0. This is equal to 910 by 1000 into VBW. So 1 okati rendu more. So this is 4 plus 0. So no problem, no point in writing the 0. 4 is equal to how much? 91 by 100. 91 by 100 VBW. So VBW becomes equals to 400 divided by 91. That you have to calculate and tell me. 400 divided by 91. So that's around 4.39, 4.4. So this is 4.4 meters per second. So you can write the wooden block with the, pardon my handwriting today, embedded bullet moves with a velocity of 4.4 meters per second in the direction of the bullet. Who gave me the right to say in the direction of the bullet? The sign that I got the same plus sign. So 4.4. Very interesting piece of problem. Now we'll see. ये तो firing नहीं था. This is not firing. This is like Rishika was thrown into a swing. She sat into the swing and the swing then moved. Combined mass system. Acha. Any doubt for anyone? So first, physics is not about putting a formula. Physics is about understanding the scenario, and then maybe you have to twist it, massage it, and then a particular formula will be applicable. Correct? Kuch aur problems? Aye. So there are some problems in this book. Okay, let's do this problem. This is not exactly on, this problem is not entirely on Newton's third law, but this problem uses the entire knowledge of this chapter. Ready? Let's see. So a bullet of mass 20 grams. Let's listen to this first. Okay, you have a bullet, and the mass of this bullet is how much? 20 grams. This bullet is moving with a speed of 120 meters per second, and it hits a thick muddy wall. There's a muddy wall out here. Okay, Peppa Pig would have been a muddy puddle. I'm writing puddle only. So muddy wall. The bullet hits a thick muddy wall and penetrates into it. Okay, penetrates into it means my bullet has gone till, say, from at this position. The bullet has penetrated and has hit at this position. It takes 0.3 seconds to stop in the wall. That means this time is 0.3 seconds. Till here, have you understood the problem? A bullet is fired with this much velocity and this much gram. The bullet goes and hits a muddy wall, and the muddy wall is acting as a resistance, and it takes 0.3 seconds for the bullet to stop. After that, it goes penetrate and stops out there. Number one, we have to find out what is the acceleration of the bullet in the wall. The first question, acceleration of the bullet in the wall. Now you yourself think, once the bullet has hit the wall, did it accelerate? Nitya, sit straight, na? Otherwise you'll feel dejected. Did the bullet accelerate? It cannot accelerate. If it accelerates, its speed should have been more. It should have crossed the wall. It has come to a stop. Yeah, so we do not say acceleration. Acceleration means speed going up. So the bullet has actually not accelerated. The bullet has decelerated or retarded. That means our answer for the acceleration should come negative. If I magnify this much portion, this is the entire journey of the bullet, right? At this portion, the speed of the bullet is equal to 0 meters per second. Agreed or not? When the bullet hits this wall, the speed of the bullet is how much? 120 meters per second. What is the time involved for this travel? 0.3. S equal to ut plus half at square. No, you don't know how much is S. V equal to u plus at? Yes. V equal to u plus at will give us what is the acceleration. I have no more writing because otherwise we'll fall short of. V equal to u plus at. What is the value of acceleration? Acceleration is always final velocity minus initial velocity divided by the time that has elapsed. So it's 0 minus 120 divided by 0.3 divided by 0.3. So how to do this calculation quickly? It's 120 negative divided by 3 by 10 which is negative 120 into 10 by 3. So this is 3 4s are 12, 40. So this is a negative 400 meter per second square. Look at the acceleration. The speed is reducing at 400 meters every second. So in 0.3 second, the bullet came to a stop. Did we understand the first part of the problem? All of you? Right. The next part of the problem. Now these problems are interesting. They will combine the whole chapter's knowledge. The force exerted by the wall on the bullet. So definitely the wall has exerted a force. Now force exerted by wall on bullet. Generally we know force F is always equal to mass into acceleration. Now look, this is my bullet. The force is coming on this side, the bullet is traveling on this side. So our force will always come negative in this case, which tries to show that the force is acting negative to the direction of the motion of the bullet. Right? The mass of the bullet is known to me. The mass of the bullet is how much? 10 gram. So it is 10 over 1000 kg. Right? How much? 20 grams? Okay. So 20 over 1000. Agreed? Now, whichever direction the force is, the acceleration is always on the same direction. Do you get it? Now, there are two ways. Children many times get confused to say, sir, should I report a plus answer or should I report a minus answer? I would say like this. Bullet is facing an acceleration of how much? Negative. So that means if somebody is giving the force from this side, if I'm giving the force from this side, the acceleration should be positive 400. But I'm supposed to solve the problem from the perspective of the bullet. My velocity, my mass is blah blah, and I am facing a negative acceleration. So my acceleration is how much? Negative 400 meters per second square. Agreed? This and this gone. What happens? This and this also gone. So how much am I facing? Negative 8 Newton is the force I am facing. That means, now look what the question is. The question is, find the force exerted by the wall on the bullet. So I will write, no. The force exerted by the wall on the bullet is 8 Newton. You are solving the problem from the bullet's perspective. So the bullet is facing negative 8 Newton because the force is coming opposite. So we will say the wall is exerting a force of 8 Newton. So you got negative 8. Did you understand this? Is this clear with all? Take the bullet. Forget everything. The bullet stopped. Why did it stop? Somebody must have given a force from the reverse direction. Why did the bullet stop? Somebody must have given a force to the bullet to stop. That means the bullet must have experienced a force in the opposite direction. Let's calculate that. What is the mass of the bullet, you know? What is the acceleration the bullet is facing, you know? Mass into acceleration gives you a force. The force came negative 8 Newton. Now you need to justify what is negative 8 Newton. I am a bullet. My direction is in this. I am experiencing a force of 8 Newton means the force is kicking me on my tail. I should go with a more higher velocity. Me stopping means the force is acting opposite to me. That's why you got this as negative. If you see from the other perspective, they gave a force from this side. For them, it is their 8 Newton positive. It is asked, they have not asked what is the force experienced by the bullet. They have asked what is the force exerted by the... So here we should write one more thing. Wait, the bullet experiences a force of negative 8 Newton. That means as per Newton's third law, the wall should exert a force of positive 8 Newton. Action, reaction. That's how the story comes. The bullet experiences a force of negative 8 Newton. So the wall must be experiencing a force of positive 8 Newton, equal and opposite. Yeah, so the next question, see. So what is the answer we will give? We will give the answer as the wall exerts a force of how much beta? 8 Newton. The next question is, what is the force exerted by the bullet on the wall? The force exerted by the bullet on the wall is also 8 Newton. Magnitude wise is same, na? Equal and opposite forces, but directions is opposite. Finally, it says the distance covered by the bullet in the wall. How much did it penetrate? For here we can use S is equal to ut plus half at square, or you can also use v square equal to u square plus 2as. Either of the equations will give you the problem. Have you understood? Now let's twist this problem more. After embedding, say after getting in or some sort of problem, it moves, suppose the question was, it moves with a steady velocity. That means this part acceleration will be 0. There can be some questions, right? A ball travels and enters into a tunnel. After it has entered into a tunnel, the ball is traveling with a steady velocity. That means there is no acceleration out there. That becomes like a grade 6 problem. Distance traveled equal to speed into time, because the ut portion is the only portion that is effective. Half at square becomes 0 because a is 0. Is that clear? Acha, this is one last problem. Let's see you can decode this or not. Okay. Last problem. Again, from the whole chapter. A box of 50 kg is kept on a horizontal floor. A box of 50 kg is kept on a horizontal floor. Problem is very interesting. Listen to it. When pushed by a horizontal force H, when pushed by a horizontal force H, it moves with constant velocity. It moves with constant velocity. I'll see who can actually explain me this problem. Right? Further it says, if pushed by a horizontal force of 1.5 h, right, it moves with an acceleration of 0.2 meters per second square. It moves, 0.1, okay? It moves with an acceleration of 0.1 meter per second square. You need to get me the value of h. Don't try to solve it. Decode the problem first. Get me the value of h. How will you decode this problem? First, understand, when the body was pushed by h, it moves with constant velocity. When the body was moved with 1.5 h, it has a acceleration. I need to find out the value of h. Force is mass into acceleration. We all know mass of the body is given. Mass is given. Acceleration is also given. You need to find out the value of h. All your brains are going to are busy working numbers. I'm least interested. I'm least interested in numbers. Force is mass into acceleration, I know. What is your learning from this chapter for this problem? That does not need any pen or any pencil. It just needs your brains and your mouth to speak. Aapka sara, you all are all behaving like Karnas of Mahabharat. During the main battle, every knowledge has gone waste. What is the first scenario as per Newton's first law? Newton's first law. Again, you are mugging up and saying, there's nothing about rest. The velocity is constant. That means no force is acting on this body right now. No force is acting. This force has balanced all frictional and other force. That's why. Because I told you in first class, if there is net force, there will be acceleration. Is there acceleration out here? So there is no net force acting out here. When there is no net force, a body moves with constant velocity. But here acceleration came up. Up to h, net force is 0. When the force became 1.5 h, acceleration was born. So what is the net force on the body? 0.5 h. 0.5 h is the net force acting on the body. What they have hid you in this direction, in this is, why is there no acceleration though you are applying? There must be some frictional force, some wind velocity, air resistance. All these has cancelled this force. So you're moving in it. A body in motion continues to be in a state of uniform motion unless and until it is compelled to change a state of frost or uniform motion, and that compelling is done by a net force. In this case also, we had our friction, we had our air resistances, but all these added up to give you how much? H. That's why H and H cancelled, no acceleration. This is same as a body with no force, and it is moving with constant velocity. This problem, second scenario, is that the body is now with H 1.5 h, so 0.5 h is the net force acting on it. And now we will put our application. This is equal to mass into acceleration, and we can calculate what is the value of h. Physics is interesting. इससे पहले वाले जो problems थे ना, those were typical CBSE problem. Formula, ma'am, I got 28.3. He also got 28.3. It's correct. Ma'am has given me full marks. This is where you use your gray matter. ठीक है ना? H to H is balanced. When that delta came, I give you so many examples. That delta can be created by a slope. That delta can be created by somebody pushing you. A delta has to be created. Only then the body comes into acceleration. So now our calculation is very easy. Half h is equal to, how much is the mass? 50 multiplied by 10 by 100. So 2 takes away 50, 50 and 50 cancels. H value is equal to 10. H is a constant. So H value is equal to 10. Okay? So enjoy your good time for next 2 classes. Yes, darling, tell me.